Howdy folks, Tom Barbalet here. I'm just going to release a whole series of bits of audio into the Biota feed before I leave for Australia. I think that's probably the easiest way to do it rather than doing timed releases while I'm in Australia. And somewhat topically, this first podcast was recorded on Thanksgiving Day, and Gerald Jong talks about his Darwin at Home project as it is currently and how he projects it into the future, which probably makes up for some of the audio that was cut in the last Biota Live, so apologies again to Gerald, and hopefully this makes up for it. Eric Burton also features in this recording, and Eric Burton is currently hospitalised. Our thoughts go out to Eric at this time, and hopefully he'll get out of hospital soon, so he can resume his amazing and lucid discussion associated with the Biota development. It's really critical to have folks like Eric Burton in the feed talking about artificial life. I also wanted to give a slight update with regards to the International Society of Artificial Life's election. The election is going on currently. Please go to the Grey Thumb blog for more information. You have to obviously join the International Society within the, I guess what it is now, 55 days, but 60 days from the date of posting on the Grey Thumb blog in order to participate in the elections. So, if you're interested, please participate. I've had quite a bit of correspondence with some of the folks who are on the ballot with regards to hobbyist and industrial artificial life developers, and also bringing together the academic teaching of artificial life, the core curriculum discussion, which has been wonderful. It's good to know that folks who are at least nominated for the International Society board are thinking along the same lines. Let me take you back to Thanksgiving Day with a chat with Eric Burton and Gerald Jong. Welcome to Biota Live. I'm Tom Barbalet, and this is a continuation of the Biota podcast. For more information on the Biota podcasts, go to biota.org/podcast. We have our first caller on the line.
Hello there, Tom.
Hello, Gerald. Good to speak to you on this Thanksgiving Day. I guess for you it's just a regular Thursday evening.
Yeah, that's right.
So this is a slightly irregular show. I'm not sure when it will be aired, but I'm going to use it as filler material while I'm travelling to Australia. So although it is Thanksgiving Day, and we are talking about what we have to give thanks for as artificial life developers, it may actually be aired probably in January or even February next year. But I was curious to get a kind of project update associated with what's going on with Darwin at Home currently, and if you're talking to folks listening to this podcast in January and February next year, what kind of exciting stuff do you predict will be occurring around then?
It's a little hard to predict, unfortunately. I'm not getting the sort of regular time to spend on it that I had kind of hoped for, but there's sort of too much revenue-generating activity that's possible right now, so I'm going to take advantage of it. That being said, I do end off the day with enthusiasm left to code in the evening, and I've been building the odd thing here and there, and then taking an afternoon in the weekend and stuff. So I'm really I'm on the case. It's just that I was kind of expecting to have full days to work on it once in a while, but that hasn't quite materialized. I'll probably steal one once in a while, but it's not going to be frequent.
But in terms of where you are looking to take the project, you've had some discussion via the Biota Conversations mailing list associated with it moving towards a kind of multi-participant online environment. I mean, what's your view with regards to the future of Darwin at Home?
Well, that's indeed what it's intended to become. At least I'm working hard to get it to a state where it's you might say sort of a poor man's second life or something, but then with a very different aesthetic to it, and also with some form of evolution involved. And the ideas are starting to congeal. It's starting to look like I'm really looking to find the sort of the smallest amount of work I can do to get something reasonable up, because part of it is social. I mean, the one thing I just completed and podcasted about this morning was I have a chat system working using HTTP, so that's going to be integrated into the program upon its release. That means people will be able to hang around with each other via the program. The whole thing is going to take place on the surface of a sphere, so they're actually going to be walking on the sphere, whereas before the sphere was only used for sort of storage locations. But now they're actually going to be encountering each other as well, hopefully. I've been going through all sorts of steps to build the building blocks for this process, like, for example, being able to turn a Darwin at Home body into bytes and then back into a body, and, just having that marshalling and unmarshalling working. And besides that, I've got the database system working with which stores the genealogy, so you can trace back parents and ancestors. So these are all just sort of building blocks. I've got the sphere scenario where you sort of arrive at the planet and then descend to the surface, and then you can travel around the surface. I've also got bodies appearing on the surface. And I've got them building using the blind watchmaker reading from the binary genome. So there's a whole bunch of building blocks in place. The challenge will be to make the last steps to get something out that sort of resembles, you might call it a game, because it'll involve, of course, more than one person. And if I'm able to do it, I will have, like you'll be sort of putting your evolved creatures in battles against other people's evolved creatures, and part of the challenge will be to dedicate the time on your PC to perform the evolution to get the most talented bodies to fight your fight. And there's one essential element as well that I'm definitely going to be able to integrate, probably from the beginning, even though the rest of the scenario is probably not quite live yet. But the idea of taking snapshots using Povray, because that produces such a lovely rendering. And what I'm going to do is have the server continuously taking snapshots, so effectively compiling a bunch of movies in parallel, very slowly. So they're going to be storing snapshots of what's happening, and I should be able to compile those into movies. So I want it to become a real movie-producing machine too, because as you know, that really is a medium that catches hold. We now have quite a full site at imdarwin.org, right?
Oh, it's getting there. It's getting there. I mean, hopefully by the time folks listen to this podcast in the future, there'll be quite a few more. But I think a number were recorded at a recent Gratham Silicon Valley meeting. So I'm waiting to hear back from Al Lundell, obviously, over the Thanksgiving period. Email seems to take a little longer and wait in trays a little longer. But my hope is that I'll have between half a dozen to a dozen more I Am Darwins from Gratham Silicon Valley alone, and certainly I'll put the word out to the Gratham Boston folk that they may consider following the same process. But returning to what you were talking about, I can't remember whether it was one of the last versions of Fluidium or one of the early versions of Darwin at Home, but I remember a version where people could save their particular forms. And I can't remember whether there was a comment or voting structure, but there was certainly a way where the forms could be saved and attributed to various creators. Do you remember that technology specifically, and is that something that you're thinking of moving into a constantly moving store of these saved creatures? Would they be wandering over the sphere versus just kind of in a holding library pattern? Is that your thinking?
Yeah, I mean, the way it was, that's actually the Build Evolve version, which is still online. I think it still works. I haven't looked at it for a long time, but I think it works as it always did. And it's the one that presents a graph of fitness, and you can have a lot of fun sort of watching the graph sort of jump up and then level out and stuff like that. And what I had there was a kind of a folder mechanism, just sort of your standard tree structured folder mechanism with the added extra of being able to sort of store bookmarks to your favorites. And I also had set it up so that there were a number of favorites available as soon as you start up the program, even if you hadn't signed in. And so that was sort of, straightforward file system like. And for the new program, it's got to be completely different, because your creatures will indeed be running around the surface and hopefully getting into trouble and getting attacked and attacking and stuff like that. So it's intended to be somewhat of a game. Like I said, the whole time, each creature will be sort of carrying a camera behind them, which films what they do, and these will be able to be turned into MPEG movies afterwards. And the whole while, people can chat with each other.
So this may be quite a dangerous question. You've described battling and making movies of the various battles, but is there going to be a mating and mutating component to it as well?
Yeah, mating I'm not sure about because I haven't necessarily needed it up till now in Darwin at Home, so it might be an option. It depends on a number of things that develop. I mean, the thing, there's still some serious development between me and something that works well right now because, and maybe by the time people hear this, it's completed, but I have to figure out a way to do the behavior of the creatures, or I'd like to figure out a way to do that with the blind watchmaker code so that, you're reading instructions and as a result contracting muscles. And it would be nice to have that mechanism used as well for behavior. I mean, it could always fall back on the way I did it up till now with Darwin at Home with springs in, each spring deciding on its own and sort of the genome integrated into the body itself. But I'm going to see if I can do it with the blind watchmaker so it's like the genome, doing the puppeteering. And the evolution component of this will be not what you might expect. I mean, if you're thinking of evolving complete creatures that are deciding what to do and evolving strategies and maybe working socially and stuff like that, that's not where I want to go, at least not for starters. I'd have to have probably some other people involved to make it something like that. But for now, I thought there's an advantage to sticking with what I've already done to some degree, so it's familiar enough that I can do it in the limited time that I have. And also, I don't know if I have a strong interest in creating the brain of this thing myself. What I'd like to do is have people be the brain. So essentially, you tell your creature where to go. You sort of click on a destination, like in those strategy games, like command and conquer sort of things. You point at something or you circle something, and then all your little creatures go that direction. So the idea is that you sort of steer your Darwin at Home body around, and also probably give it the goal of if you see another creature in the neighborhood and it seems to be one that you could probably defeat, then the idea would be to sort of point your creature at that creature and give it some time on your PC to evolve the ability to walk in that direction or to turn that direction and then walk in that direction. So the idea is to have it, acquire its motor abilities with a human at the helm.
And talking of collaboration, I know you were doing some work with Scott Schaefer previously. Is that continuing on? Is this what the Blind Watchmaker Code fundamentally became?
I think Scott has gone back to working for more or less full time these days. As far as I've heard, he's sort of taken a break once again from development. It's hard to maintain, of course. When you have to go back to spending your whole day coding for someone else, it's a little difficult unless you're insane like some of us. Testified.
Yeah, definitely. So the topic for today is what to be thankful for, and you've touched on a number of these components just in your discussion associated with Darwin at Home, and I mean particularly the time component, the long-term nature. I mean, you've been through Fluidium, through Darwin at Home, you've been developing artificial life for, roughly 15 years now, maybe 12, 15 years, that kind of time frame?
Yeah, that's about it. Yeah, I started with just experiments with geometry back in the beginning with springy structures. I was thinking in terms of Buckminster Fuller and engineering and building things. And it's only later on that it turned out to be something more applicable to artificial life, and that turned out to be a lot of fun. So it's been a long haul for sure. Yeah, I think. Hey, if you want to know what to be thankful for, I would say number one is the internet. Because this kind of stuff is sufficiently esoteric that it's a little difficult to find kindred spirits in your neighborhood. Certainly. I was talking to Eric Burton last night. He's posted occasionally on the Biota Conversations mailing list. And it was a fascinating discussion that touched on a number of topics, including George C. Williams. I'm not sure if you're familiar with his work, but he was an inspiration to Richard Dawkins, but also was an instigator with regards to Timothy Leary. And it's an interesting then, if you hear Timothy Leary's Cooper Union talk in, I think, 1964,
it is basically the selfish gene in speech form coming from George C. Williams. It's fascinating, the kind of folk who are part of the artificial life community, and certainly through things like Biota Live and the Biota Conversations mailing list, we have a group of sometimes like-minded, sometimes not like-minded individuals that can kind of congregate in an electronic form and put out these crazy ideas in some regard. But I mean, returning to the idea of time as being something to be thankful for, a fundamental advantage. I mean, I think from your development, you've concentrated very heavily initially on both Buckminster Fuller's work and Dawkins' work. In addition to those two, clear polymaths that have touched a number of aspects of contemporary thinking, I mean, have there been other writers and thinkers that have impacted your work?
Well, definitely Daniel Dennett. I remember being inspired by stuff from Arthur Koestler quite a while ago. You remember Arthur Koestler? Have you ever read any of his stuff?
Familiarize the listeners and me quickly as well.
Well, he had one of his books, I think, was called The Act of Creation. It was one of these big suckers. Takes a while to get through. And there was another one. I'm not sure that. I think it was called what's that two-headed creature? Greek creature?
Hydra.
Yeah, it was called something related to the Hydra.
Right.
But it was about the holarchy, like the idea of everything sort of being somewhere in not necessarily a hierarchy, but as far as you can tell, there's up and there's down. So you're just somewhere in a holarchy. In some respects, you're a whole, and in some respects, you're a part. And that's true for basically everything all over the place. So he explored the idea of sort of being a node in a hierarchy rather than looking at the whole hierarchy. Interesting.
It's just the idea of the Gestalt as well, in terms of you being more than the sum of your parts.
Yeah, well, what he's saying is that there are two sides to everything. You know, there's partness and there's wholeness.
Certainly. I mean, I think this is an interesting part about developing artificial life, that really you can draw from a number of sources in terms of how you come to creating your simulations, and also what you then utilize your simulations in terms of future discourse. I mean, we've had this discussion periodically through the Biota Live podcast, Gerald, but do you see a time where you've talked to an audience of architects, for example. Do you see a time when you talk to an audience of potentially psychology or sociology, or a diversity of potential university students with regards to what you've done with Darwin at Home?
I'm not sure if it would go to the, as far as psychology, something along the lines of mechanical engineering might be interesting. I've been invited to talk at a skeptics conference in Budapest. So that will be in September of 2009. That should be interesting. So that's a conference for skeptics. Now, I don't know. It's hard to say what actual academic discipline it's related to, because it's sort of a bit of everything, and it's also sort of outside of the field in a way.
Certainly. I mean, I think this is a topic that you raised for a future Biota Live with regards to the idea of an artificial life curriculum. And certainly in my own thinking, and particularly reflecting on this idea of the amount of time and also the amount of reading that has basically gotten, contemporary artificial life developers to where they are, it's very difficult to think of a single rigid discipline, or even a short list of disciplines that would be critical in order to develop artificial life. I mean, my own reflection is really that this is where time is critical, the ability to kind of pick and read and experiment and break and kind of tape back together, this kind of narrative. So what kind of stuff will you actually be talking on at the Skeptics Conference?
Oh, it's a long time away, so I haven't thought about it very much, but I hope to be able to give a good demonstration of Darwin at Home. The guy who invited me, it's an academic locale, venue, and the guy who invited me was also very interested in seeing how perhaps some students at the university there could use Darwin at Home in their studies. So that might be an interesting entrance to at least the Eastern European academic world.
Fascinating. And this is something that interests me with regards to the idea of time, is that we are able, and you've described various components of Darwin at Home and Fluidium that are actually, medium-sized engineering projects, certainly for a single engineer, and something that requires a long period of time of planning and coordination. I mean, I get the sense that you do maintain a lot of the older code that you've written with the hope that it'll be usable or reintegratable at a later stage. Am I right in my understanding of this?
Well, in the last few months, I've been really sort of combing the beaches of all the code I've had built until now, and I've really been just stealing the good ideas and giving them a new form with the new stuff that I've learned in the meantime. Because of course, you learn as your career progresses, and I look back at some of the stuff I wrote before, and I think, okay, time to review that a little. But it's a good opportunity to review all this stuff, and I've been actually able to snag most of the good ideas that have been coded into previous versions and integrate them all into Fluidium Core, which is a library that can be used, just to create a shell around it. It is not very hard, and then you can do a lot of fun experiments. I'll probably develop that even further, especially if people in the academic world eventually want to use it. They'll want to be able to plug in different algorithms and different strategies and things like that. So I've been able to comb it for the good things, and the code has been left behind, actually, as it is, for now at least. I mean, I've been able to recycle the best ideas.
Yes, as I sit talking to you, I have in front of me my library case of CD-ROMs burnt over and well more than a decade, and certainly containing a number of bits of Noble Lake gems, and as you say, also discarded components as well. It's certainly a question that Eric Burton raised, which has been raised in previous Biota Lives, in terms of actual project integration. Do you think that, within the next 3 to 5 years, some of the elements of the Evo grid will lead some of us to actually start integrating our projects in a more meaningful way?
Well, you gave it a nice wide time frame. If you say like 3 to 5 years, then I would say, yeah, sure. I'm sure something will start to develop in that kind of a time frame. I don't see it really happening all that much on the short term, but and then again, of course, it might never happen. But I think there are a lot of opportunities, and I have a sense that the opportunities are increasing in a way, because we're learning a lot more about how to glue things together, and there's a lot more gluing happening with things like dynamic languages, and I'm trying to think of the English expression now. It's really easy to cobble together a domain-specific language, for something like Groovy or Ruby. So, there's a lot of script kiddies who could start doing much more of this stuff, because at a certain level, it's all sort of scripting anyway. It's only at the lower levels that it really has to perform at high speed. Like, for example, my son was playing with a game a while ago, RPG Maker, I think it was. And it's set up so that you can build your own sort of humble RPG. And he was doing this with another guy, I think from Germany. And you code the behaviors in Ruby. So, I think that's a sign of a sign of things to come. There's going to be more scripting and more, the tiny domain-specific language approach, I think, is going to be more and more important.
Yeah, it's an interesting question. I mean, certainly within the next couple of years, I would like to do some integration between Noble Ape and Polyworld, and that's primarily because they have a number of overlapping components, but also they share relatively the same language space in terms of C, C++, those kind of flavors. But I think I agree with you fundamentally that the ability, and this has been started with the Python collaboration projects and these kind of things, to use the higher level scripting languages will actually produce a very interesting series of new collaborations and new artificial life projects. You've talked a little bit there about the idea of computing speed and the fact that through these kind of higher level scripting languages and just the immense power of contemporary computing, a lot of the low-level optimization that really was the stickler of those of us that started, as you say, 12, 15 years ago, is no longer really the case in terms of the new possibilities. When you think of contemporary computing speed, do you feel that you need to do any additional optimization? Do you feel you need to atomize your simulations or look at putting in additional multi-threading or multi-processor or network processing or these kind of things in your code? Or do you feel that it will come for free through, future or existing scripting languages?
There's, a piece of software these days is made up of a whole bunch of layers. It's like ice cream with on top of the cake, and then icing on top of that, and then whipped cream on top. There's all sorts of different layers. Down at the very bottom, of course, you got the deep machine code and the operating system. On top of that, in my case at least, there's the Java virtual machine, which was written by a merry band of freaking geniuses and PhDs and all sorts of contributed work from all over hell's half acre. So there's a lot of brilliance built into the virtual machine, and the same is of course true of the Microsoft offering, which I just happen to not have experience with. Then on top of that, you've got the sort of you call it the managed language, with conveniences like garbage collection and stuff like that, and on top of that, you've got the really sort of fluid languages, your Python, your Groovy, your Ruby, things like that, where it becomes really a breeze to make little efforts in scripting, and that's the very very top of the icing on the icing. It doesn't have to perform very quickly. Because it's sort of orchestration instead of down deep code. So there's all sorts of levels. The Java virtual machine optimizes its brains out on your code that you write. It's when you start up the virtual machine, it starts optimizing, and as you're running the program, it optimizes further. So the hotspot compiler takes certain pieces of code and re-optimizes them and makes them even faster, and that can even happen in multiple occurrences. So there's all sorts of things going on at the many levels, and we're really getting that whole stack built up nicely these days. Programming has changed as a result, and at the very top level, you've got these dynamic languages, which are really convenient for the orchestration. I'm thinking myself of having the blind watchmaker instruction sets being coded in Groovy, because that's probably going to be quite easy to integrate into a GUI application. I could just present a sort of an editor, and you can, it's all very terse code in many ways. It's very very typable. So if I can have gene instruction sets coded in such a dynamic way, then it opens the possibilities for going beyond what I was just describing, where people are puppeteering, to getting to a situation where scripts are doing some puppeteering, and that might interest people like my son, for example, and it might open doors to academics as well. You can do all sorts of stuff. A domain-specific language could glue a neural network into the rest. It just plays the glue role.
So, my thinking has gone down two separate tracks as you went through this narrative. But the idea of a domain-specific language here, you're talking about an artificial life-specific language fundamentally.
Yeah, not necessarily one. A variety of them.
Do you see?
For example, I might be able to develop a really, the clue is that it's just so easy to develop a little DSL, a little domain-specific language, but I might be able to create one that makes, the building of an instruction set really, really brief and straightforward. It becomes sort of the way to go.
It's an interesting problem because I think certainly Microsoft is currently trying to tackle this with their AI and robotics group that are cobbling together a domain-specific .NET compatible AI and potentially into A-Life specific language that they want to initially sell to folks that are developing robots, but no doubt in the future sell to other universities. It's under the Microsoft openness idea as opposed to it being open source. But I think the other thing that has been echoing through what you're saying is I work with folks at Apple and folks at Intel, and I worked with the high-performance optimization group at Apple, who gave me a short list of things that I should never put in Noble Ape if I ever wanted it to be considered for use with what they did. And I think my current problem with Noble Ape is that there is a whole lot of very low-level stuff that was specifically designed and optimized for Intel processors, which has some advantage because they are still the standard processor in some regard. But I think it's an interesting problem because as with Brevet, as with a number of these longer-term, starting with C, C++ style simulations, I'm thinking of Polyworld here as well, the issue with regards to interfacing, and most contemporary GUIs are in this realm as you're describing, this relatively high-level, almost scripting language-like interface. I mean, certainly Cocoa on the Mac is fundamentally like that, and I think a number of the other scripting-style GUI layout languages that folks would be using to create the interfaces to their artificial life simulations in the future. So I'm certainly very sympathetic to what you're saying. My question back to you is with regards to various physics, ideas of weather, ideas of things that you may want to integrate in your simulation environment, which is still pretty well served in terms of a low-level, be it SSE or some kind of optimized low-level method for generating vast simulation environments, weather, physics, these kind of things. Do you see that as being something that would run in parallel and have some scripting interface, or would you like to see all of those components in a high-level scripting as well?
There's certain things you don't want to do at the scripting level. Like I said, it's icing on the cake. It's relatively dismally slow comparing to what can be done at lower levels when you've either got bytecode that's optimized or stuff that you've personally hand optimized. So there's one thing that I would love to have sort of access to, but I don't have the time to figure it out if it is possible at all. It probably is, but I mean the idea of harnessing the GPU to do some physics. I'm sure that's been done. There are websites about it and things like that, and that would make that would open up possibilities for doing a lot more physics than what I'm doing right now. So that would be an interesting approach. Maybe somebody in the academic world can take that on as a project. On the other hand, of course, you lose the flexibility that you have when you write in something like Java bytecode, because you're sort of coding on top of a blanket, and the blanket can be laying on top of an Intel machine or a PowerPC machine or whatever the hell else. So it's sort of like it insulates you from the hardware level, which I've always thought of in terms of artificial life. I've always thought of that as a survival trait. Yeah,
in some regard, I agree with you. I mean, I think the low-level stuff that I do with Noble Ape is specifically compiled for specific users. But I think, there's an interesting...
You kind of have to be ready to discard that sort of low-level stuff because things will change, hardware will change. I mean, not discard it, but I move on to the next, and that can take a lot of effort.
In some regards, yes. I mean, I think what I've tried to do with Noble Ape is recycle the underlying methodology, certainly with regards to the movement from Altovec to SSE. I used translation tools which Apple actually picked up internally, primarily because there was so much time that could be wasted in re-hand coding SSE if I had already existing Altovec code in terms of optimization. But I think there's an interesting problem that there are still components of computation and still things that you may want to integrate in artificial life simulation. And as you describe the use of the GPU with regards to physics, I think there are a wide variety of exciting artificial life processes that the GPU is ideally suited to handle. I mean, my understanding, although it's a relatively high-level understanding from listening to your Darwin at Home podcast, is perhaps the blind watchmaker code could be ideally optimized to run on a GPU, serial processing pipeline. And I think the ability to have this knowledge in the community means that we can create, these kind of future, potentially high-level scriptable, but certainly still interfacing the low-level power of contemporary computing. I mean, when I think about Noble Ape, but also things like Polyworld and potentially a vast number of agents of Darwin at Home kind of forms eking their way across the sphere, I mean, these all become still heavy processing problems, and I think we need, as a community, to have an internal knowledge base associated with how we actively optimize these kind of things. In terms of
my approach for Darwin at Home is interesting on that front, because on the one hand, I've got now a huge problem, because I've got I hope to have hundreds and hundreds of creatures crawling around a single sphere. There's a strong advantage to having that happen in one place, rather than trying to figure out a way to distribute it, because it's very complicated to distribute something like that. The approach I'm taking is to go slow motion. So the idea is then that every creature gets to experience a very small slice of time, and then it's put back to sleep. So the server can just stroll around from one to the next and pick them up and give them a little time and then put them down again. So that's the way I'm taking care of the computational issues.
And this fits into your idea of film rendering as well, because I mean, obviously, if it's doing, if you're already doing slow time slices, you can be utilizing some of the time to do rendering as well. As you're talking about something that is fundamentally kind of client-server distinction, I mean, what's your idea with regards to the server, and is there going to be a separate server that does the film rendering, or will it all be done on the single server?
Yeah, well, film rendering is something you would like to do. It's attractive to do that in a distributed fashion, because it's a lot of work to get a few films. I've had my machine running overnight a number of times, when I was generating those renderings. I know that it's computationally intensive. Nice to distribute that, but I haven't figured out a way to do that in a way that I can, make it easy enough for people. So instead, I'm just going to have this process that gives them all a little time slice. What it's going to do is give them a time slice, take a picture, and then put them back to sleep. So the server will be generating I've decided to use sort of like the iPhone format, 640 by 480. So these are small images, and I'm just hoping that it's not, imagine the thing just sort of creating one snapshot a second. That's the kind of pace I'm thinking of. Certainly.
And in terms of the size metrics, in terms of the kind of processing that you're expecting to be performing, do you have a sense of the number of forms that will be strolling over the sphere, and do you have a sense of the kind of server interaction that the users will have?
Well, I have. I've got to have several hundred at least strolling around the sphere. I mean, the beauty of a sphere is that they can't help but encounter each other, because there's just nowhere else to go. So they, even if you walk in one direction, you'll eventually encounter somebody.
I don't want to interrupt you, Gerald, but we have another caller on the line, so I just want to bring in. Hello, second caller.
Oh, hey. Hey, this is Eric Burton.
Hi, Eric. Good to talk to you again.
No, I know. I heard I was hearing your show again from a few minutes in, and I thought I would just call and try to say hello to Gerald and Jong. I saw his Darwin at Home video, and he's doing very good work right now.
Thanks a lot, Eric.
Very good work. What I was hearing when I phoned is the kind of crazy, heavily parameterized stuff I was discussing. I mean, I was thinking earlier, if we could have MMORPG designers, I'm sure none of them have tried evolving the scripts that, for instance, drive NPCs and towns around on their day-to-day activities just based on how many meals they eat and, an energy level, and running billions of them around in towns. a day.
Yeah, well, Eric, this is
behaviors instead of writing them by hand.
Yeah, Derek, this is interesting in the context of the approach that I'm taking with the blind watchmaker, because there's the idea of evolving a script that sounds pretty scary in a sense. You can't really imagine some process sort of accidentally writing script code. So what I've done is I've sort of turned it around. I've made it so that the instruction set of possible instructions is coded out by a programmer. Hello? And the actual script is written in binary.
Yes. No, kind of written out by hand in a sort of a binary format, eh?
Well, it's not written by hand. It's written by a random number generator. But so the idea is that you can create an instruction set. You can say what's possible, what can be done. But that's where you have to stop with the blind watchmaker. You have to say, okay, well, here's the instructions. This is what's possible, and then you hand it over, and the actual randomly generated genome pushes the buttons and turns the knobs.
Various forms. I mean, even a non-Turing complete instruction set may be able to solve still most problems in an arbitrary sized program. It isn't always clear. It depends, which is why we have really a great deal of leeway in coding these genetic codes. But at the same time, like we were discussing yesterday, I see some virtue in having sort of a neural architecture that is explicitly defined. Even if you had a copy of the one that's there at birth, so that the parent's learning isn't passed on directly to the children, which would have an impetus then for communication between parent and child. I think that you could have a genome for the phenotype and some aspects of the behavior, reflexive aspects, and then a brain. And then a brain as well, which is defined separately. I think that is a compelling notion. I don't know if it's where we're going. I don't know if it is. Well, what do you think?
Well, I can imagine a process whereby a neural network is built by the genome.
And then a brain that is actually a few megs, and it constitutes, rather than a genome, which is a few megabytes. Honestly, because then when you breed these creatures, you can be like copying a brain, just copying you'd be copying a big block of data rather than generating it. Then you can apply a few mutations just at randomly generated offsets, and have the genotype to phenotype evaluation done in a great hurry compared to that. And they can have these disproportionately massive brains like the intelligent life on Earth display. I think it makes a lot of sense. All the creature structures, I don't know, would become really big. I know a lot of people right now are still using logic or code, machine code for controllers, like we discussed. But I think some of the neural approaches are promising as well, naturally.
So, Eric, if I could ask you a question, which really I should put to all the folk that call in, and particularly who want to participate with Gerald and myself. If some terrible accident befell Gerald and you acquired the Darwin at Home project, in terms of a kind of time frame and stepping, how would you integrate what you've described in Darwin at Home?
Well, it's so hard to say. I don't know if these creatures have a controller, if they have sensors at the vertices, or what. But I think they could.
They have
brains.
They have no sensors.
It's some kind of a brain, So it's like, okay, this is the time when, if all of my feet hit the ground, then I'm no longer in a canter. This kind of thing, and then we can, and then you can really do like what's been done with I think it was Breve, where they are chasing balls or running from things, and have a neural aspect in there. I think Breve has that. I don't even know if I'm thinking of Breve or if it's.
Are you thinking of Framsticks? That sounds more like Framsticks than Brevet from my own thinking, but Brevet does have a lot of the early Carl Sims components, and he had light followers and things in the blocky creatures, so it could be a hybridization of Framsticks and Brevet there.
Yes, I am thinking of the work Carl Sims did. You get to see the swimming creatures and whatnot. It probably was. I thought he was working with some third program I had forgotten. It's difficult for me keeping the application straight at the beginning. It was a little like being a kid in the candy shop, seeing the work that had already been done, because I've been coding for so much of my life, just programming, and it just seems like one of the richest applications you could apply yourself to. I wanted to make a card counting algorithm, I remember, a decade ago. I was like, I'm going to make a program, it does not play blackjack. It figures out how to beat the dealer. It's got some genome that determines its behavior based on, which cards it's seen in various ways. I hadn't really been into any of the literature, but these kinds of applications have always stood out to me, because when you think about it, it's like, well, yes, that could go anywhere. But again, the cycles haven't always been there, really the RAM. I might be building a dual CPU box soon. I think many cores. Core per thread is where we have to go.
Certainly. And you're talking to me very loudly here in Las Vegas. My wife regularly tells me that I should use artificial life for card counting, so it makes a lot of sense. But in terms of what you're saying, Eric, is that you'd like to see sensors as being the next step in what Gerald's doing, and certainly in what Gerald's describing, particularly with regards to multi-agents, down at home forms wandering over a sphere. There needs to be some kind of sensors in that, surely, Gerald?
Well, I sort of feel like I'm killing two birds with one stone here in a way. And it's sort of, in a way, it's a cop-out. In another way, it's a good way to make it into a game. The idea of several hundred creatures competing with each other on somebody's server somewhere, and and some of them learning how to do this, and that's all real well and good, but it's not very involving for the audience. So I would like to have something where people sort of meet each other, and that there's some reason to go back to the server after you've been once. And so what I've decided to do is make the people into the sensors. So when you decide on the strategy of your creature, where it should go and what it should do, you are effectively looking around the neighborhood and making decisions. So you are the sensors. It saves a hell of a lot of programming effort. I don't want anybody to underestimate that, unless they want to come and work with me on the project to build that part of it. But I consider that to be a major challenge, and I've decided to avoid it for the time being.
Have you looked at tramsticks at all, Gerald?
Not in any depth, no.
Games with exactly this is the social networking aspect built into it, just to get you to label and trace images to train various algorithms. This would really, you could make people be the overseer function if it was fun enough. That kind of continues to bootstrap the thing from place to place and really identify the behaviors that otherwise you might not even be able to see in order to code the code to watch for. For unattended runs, it would really change the idea of the unattended run. Also the team of spectators and judges. I'm sorry. It's an exciting idea.
So is that your view, Gerald? Would you have active participants, almost players, and then spectators, or would all spectators be players, or how do you see this?
Well, the way I want to do it, it's different than anything I've seen up till now. So I'm not sure. This is all sort of on the edge of what might be possible. So I'm not speaking out of certainty at all, but the idea is this. The idea is that the world is operating at a very slow rate of speed. It's like time travels very slowly on the real world. When the client logs in, they get, when they descend to the surface, they get a segment of the world downloaded to the machine, and that segment includes their creature. And they start giving their creature instructions, and what this creature is effectively doing is it's exploring all of the possible futures for the next several seconds, and that's it. So they're all just, it's experimenting and experimenting and adjusting and adjusting and adjusting and getting better and better and better, just like the Darwin at Home programs do right now. But this is all just exploring the potential very near future, and then when the evolution has proceeded and some instructions are sort of emerging to get the job done, only those instructions go back to the server, and the creature on the server just continues its very, very slow motion life. And hopefully in the next day or so, it will start traveling in the direction that you've taught it to go.
So in terms of possible worlds, is it that the user selects the possible transition, or is there some internal fitness function that makes the selection for the user?
The way I see it is that the user just sits there and says, I'm here right now, I want to go there, and I want to consume that creature. And then on the client, it explores all the possible futures and keeps evolving its genes until it gets the ability to travel to where you want it to go. And then those instructions go back to the server, and hopefully it will trundle in that direction. Meanwhile, the person behind the creature you're attacking will receive an email with a snapshot, 640 by 480, of the situation, and be motivated to log in and start teaching their creature to run like hell.
Yeah, on their cell phone even, a page, any of these things, you can involve people if possible. Just reach out to the interested human associates in place of the higher cognition that these things might lack. It makes a lot of sense. What it does is obviously people who have neopets and this kind of thing would probably prefer to. It reminds me of the technosphere or the cyber.
No, technosphere is what you're talking about. Yeah, that's the project in London. They were at the Digital Biota 2 back in 1998.
Oh yes, they are one of the greatest. I wouldn't even say fossil records of artificial life history. It's a great disappointment that source code or even more of the formative ideas from that would be available in the public domain, because I think it would benefit all our projects now if we could have access to even high-level papers associated with that work, because it was just so phenomenal.
The stuff I'm doing right now is actually, quite a reflection of what they were doing in a way. I mean, they had their creatures had wheels on them, and it was sort of a very different kind of environment. It didn't really involve evolution at all, but there's a lot of aspects of it that I'm sort of adopting in a way.
It wasn't a window on the world, but they would move around, and you would get emails if your creature managed to breed. There wasn't a genome that mixed up the parts, and really it was kind of converging on an ideal combination of parts and placement in the world. I don't know how long it ran, but that was a good really early indicator of the possibilities. I feel like they could have given the creatures in spores and genomes of some kind, just phenotypic extrapolation. I remember Elefish, and I thought that was what Spore was about when they were doing procedural animation, where it was you would get a fish, it would generate a genome, and then the phenotype would be extrapolated from it. If you wanted to, you could crunch CPU time into an animation for the fish, pre-rendering, which you can put into a tank. But indeed, I don't believe the creatures in Spore come in different shapes and sizes at all, only kind of are generally scaled. I know in the Sims 2 they had some of this technology, but I'm really thinking more, even some mutations can occur to change the overall body plan. I mean, this is not in the scope. And it could have been. It's 2008. And,
well, that's more, that's what I'm doing. I'm the body shapes are going to evolve from generation to generation, and the body behavior will evolve during a lifetime. And I wanted to find some way to give people a reason to return to the site after they've seen it once. So the way I'm going to be doing that is tossing out the odd email, hopefully not interpreted as spam, and of course there will be opt-out options and everything like that. It seems to me like a cool idea to be to receive an email with a picture from your creature, your sort of Tamagotchi friend on Darwin at Home, because it's in danger or something like that. And then you might have to sort of rush home from work to fire up the PC and evolve a solution before it's too late. And if it's too late, you'll get an email that informs you of the passing of your creature.
Well, I like Eric's idea as well. I mean, I think it lends itself perfectly to mobile phone applications or Facebook or these kind of things as well. I mean, I think the email is just one of the mechanisms that these kind of interfaces give you with regards to communicating with people. So, Eric, I mean, you sound like someone who would be ideally suited to work with Gerald on some of these components. Is this a project that interests you with regards to either instigating or collaborative work?
Well, you know, I was really impressed with the Darwin at Home interface when I saw it. And I thought if there was just kind of a more intuitive way to contribute, obviously more people would be interested. I think if you can give as many people in the world as you can a sort of a window into the lives of these creatures and a chance to have input in scoring them and ranking them and variously blessing or condemning them. I mean, turning them over if they are in fact stuck on their backs. This kind of thing, just so there are people in there. It would be really a whole different world. Obviously, if you had a substantial number of griefers or something like this, griefers and trolls, then there would be a evolutionary countermeasure, and an arms race would ensue. It's a very rich environment you're describing. So I think people would be interested. I'm interested. It's an amazing project. I don't work in Java. I know Darwin at Home is in Java. I just recently started working with C++ a little. And that is different from C, which I find unforgiving. Python is my favorite programming language right now.
Well, this vents perfectly into what Gerald was saying, because it sounds like there's potential for a large part of this interface to be written in a language like Python. Yes.
Well, I haven't done GUIs, etc. in Python, but Python is very good for script. It's got just very few very powerful data types that you can just operate on great swaths of data in a great hurry,
Well, there are a number of famous packages that are scripted using Python. For example, Blender, I believe, has always been scripted by Python. So you can create 3D animations and stuff using Python.
Python is very good. Obviously, as a Perl person, I heard for a long time that Python people didn't have a lot of the same problems, and ever since I migrated to it, I found I only still invoke Perl on the command line. Most programs I want to express in script form, I'll write in Python now. It's that good.
So the topic for today's discussion was what we have to be thankful for, and the next of my dot points, somewhat ironically, is communication, and I think this in part comes through our discussion yesterday, Eric, with regards to this idea, and this certainly is my own narrative too, that as an artificial life developer, one can feel very isolated prior to things like the internet and podcasts and websites and these kind of things, but the ability that we have to communicate quite internationally and get these relatively abstract ideas out to the small number of the population the world over that is actually interested in these kind of things is really very phenomenal and something to give thanks about. I mean, in terms of your overview, Eric, and I know you talked a little bit about this yesterday, but I mean, you have a very high level and very detailed knowledge of the artificial life community, which appears you've gotten through these podcasts, through the Biota Conversations mailing list, various blogs, things like that. I mean, you are the poster child of the active consumer of artificial life-related information. Can you describe a little bit more about that process and the kind of insights that you've gotten through consuming these various kinds of media?
So it was very easy for me, The mailing lists are out there for anyone who wants to know what people who are working on the stuff are talking about. And that's a format I've always enjoyed. It takes me back to Usenet, or indeed to the BBS EchoNet, where you would address people, but it was a public message. Just a lot of fun. It's kind of a format that I found fomented a style of thought that I've always been comfortable with it. So there I was like, this is a good way, this is a good thing for this community to have, because I was interested anyway. And gradually I sort of figured out where I was. It took a few months, 2-3 months. It didn't take long, honestly, to acquaint myself, I think, with the backbone of the work that's out there. They, you mentioned, I don't know if you mentioned Scott Schaefer just then, but I was telling him I want the creatures in rippling loops to be able to sense a color on each of their faces if they want. Read a color from it, sky, ground, edge, or a color of another face that they can see. So they would have kind of line of sight IR. Since they have these little jets, maybe you would then see them like forming line of sight maintenance course corrections while they exchange data, this kind of thing. But only again after really, really long runs. I wanted to get that out because it doesn't seem to me like as much sort of a toy feature as it could be. It all changes. I said before, if our workstations were maybe 100 times more powerful, we could really then see something happening. I don't know if we get so much out of 10 times. But 100 times more powerful if we were working on an average, with 100 gigs of RAM, and then 200 gigahertz.
That brings me to another thing I'd like to be thankful for, and that's Moore's Law.
Do you think it's, sorry, I just want to say it quick. Do you think then the burden becomes our ability to actually utilize the processing power that is there?
Yeah, well, absolutely. I think the hardware is finally in place for a lot of disruptive new applications, and just it takes the will and the wherewithal to put them together. People with the know-how, kind of the experience with these systems. I've been working on this stuff for a long time in various directions, and I want to devote myself to something that's for the good of humanity right now. I've been on Boink a little, doing some work there, just to help. They're doing amazingly right now. Amazingly. Distributed.net. Certainly I was into, in the 90s, just because of what they were doing, open supercomputing, like that. It brings to the table a whole new range of simulations, outcomes, just calculations and computations you can perform.
And I'm not sure if you heard the section of today's discussion where Gerald and I were talking about the need for kind of low-level processor understanding. But Gerald, what's to summarize your thinking with regards to the need to utilize or understand the low-level power in order to get more out of the systems?
Oh, well, that's, when you look at Moore's Law, you realize that if you expend a whole bunch of effort in that direction, then you're going to be maybe you're just a little bit ahead of the curve as far as what's possible, because hardware keeps improving in speed. I think one of the things we have to get used to is working at a level that's at least slightly abstracted from the actual hardware. Unless you, of course, want to be on the absolute cutting edge, and it might be fun to code a certain kind of artificial life at a really low level, but it really would limit the complexity of what you could build. So I'm more interested in structuring something code-wise that is readable enough that people can really dig into it. Whereas, if it involves all sorts of esoteric CPU knowledge, then it's for a particular audience. It might be wonderful for a certain embedded application or something like that. But in general, it's harder to learn from something like that, because the more obfuscated the code is, the more optimized, the more obfuscated. It's
an interesting problem because, certainly, and this comes out to my chapter in Dick Gordon's book, but I think there needs to be a new simulation science that comes out of contemporary computing, and it will give you the ability to write on a high level if you want to write on a high level. But I think obviously, because this isn't in the public domain, and this is something which I've talked to my friends at Apple about, but when the Apple engineers first demonstrated Barbalet, they got a 16 to 32 times speed improvement with regards to what you're describing in terms of low-level tinkering. But I think what interested me from that development was an optimization of my own mathematical thinking, which then trickled on to, whether what I was doing on a high level too. And I think kind of simulation methodology that we need to have going into the future, particularly with the ideas of, as you're describing, maybe a genotype simulation running in parallel to what Eric is describing with regards to a neural network running in parallel to what I like to see in a simulation environment. I mean, these things can use the same kind of mathematical components and can be further optimized through the GPU. We just need to have some kind of discussion, some kind of understanding, and it all comes back to your next topic, Gerald, that you submitted with regards to the curriculum for artificial life, the idea that there are a new group of artificial life hungry minds that are coming up currently through the high school and entering the university system. And I think this is something else that personally I give a lot of thanks for, that we are in some regard educating this new generation. I mean, certainly the stuff that Jamie Matthews and others email me with regards to how they've used the Biota podcast, the resources, our various projects, it's all very positive with regards to the next generation of minds that will be looking at these kind of problems. I mean, is this your sense as well, Eric?
I remember reading a David Suzuki book on genetics, which hooked me. And at no point in there did he mention, computation. I mean, obviously this was in the 90s. It was the secret of life. And it didn't come up. I never connected, even when I heard about the Human Genome Project, they'd begun to sequence that. I mean, the connection to IT was not clear for me. I knew someone went into bioinformatics at an adult education center in maybe 2002 or 3, and that was the first time I heard of the field specialized to connecting biology and IT. Specialized about that? Well, honestly, A-Life approaches this from the opposite direction. We're producing genomes and adaptations and whatnot, and really interrogating the process through which the kind of self-organizing patterns that thrive on Earth emerged in the first place. If we can generate completely different ones, completely distinct ones, then we will get insight from the contrast. And on the other hand, if we can faithfully simulate the life we see here in some way, create something like it, then again we'll be in a position to profit a great deal.
And what's your feeling with regards to the next generation, Gerald? Is this something that you're thankful for as well? I mean, Mitch has given a lot of inspiration to the podcast, both musically and also in terms of ideas. You have a very primary contact with the potential next generation of artificial life enthusiasts. What's your thinking?
Yeah, well, what I was thinking just now was just the notion of, in a way, like a rock band where you've got the different people playing the different instruments and coming at the music from a different angle. Like the singer thinks about different things than the guitarist, and the guitarist is busy with different things than the drummer. And what I just imagined was a sort of an artificial life team getting together where you've got, people with different approaches coming in from different angles, but still working with sort of the same, playing the same piece of sheet music in a way because they share a purpose. So you're artist and you're a philosopher and you're your coder or two. Getting a diverse band together to make an artificial life project. That was just what I was thinking about. Things like that might happen in the future. It's going to be one of the things that plays the role of focus for interdisciplinary work. When I was at university, I encountered Buckminster Fuller's books, and I showed them to my math friends, and they said, "No, that's not math." And then I thought, well, I'll show it to the artists, and the artist said that it wasn't art, it was math. So it was somewhere in between the two, and I think artificial life is one of those, a flag that you could get several very different people standing under to do interdisciplinary efforts.
Yes, I always thought Buckminster Fuller was organic chemistry, but it could have just been because I grew up in the era of Buckminster Fullerene as opposed to his earlier architectural stuff. But I think it's an interesting idea, this metaphor of the being a single piece of sheet music that we're all playing different instruments to, or maybe each project is a individual piece of sheet music that we bring together, I guess, and things like Biota Live in terms of some kind of concert of ideas. I think it's an important point to make that, artificial life developers don't have to be coders. They can be philosophers, they can be instigators, they can be people that come from other disciplines and want to motivate our particular kinds of development. I mean, looking back over the past 15 years of your own work, Gerald, you've obviously had contact with a lot of different people, a lot of different disciplines. You've talked about the architects, you've talked about meeting Dawkins at Biota 2, you've talked about observing Biota 2 with a sense of wonder. Are the folks that you haven't mentioned that have had an impact on your work and have also been very receptive to what you're doing?
The folks I haven't mentioned, well, there was, the initial inspiration came from a community of Buckminster Fuller fans, so that was that's where a lot of it was, sort of gestated. We used to get together on a weekly basis and have chats about geometry, believe it or not. Other than that, I don't know. It's if you think, for example, about that project we were just talking about, Technosphere, that was an example of a project that involved several disciplines together, and it's true for every game company as well. They have people of completely different disciplines working together. I remember it being somewhat like that at CyberLife when we were at Digital Biota 2. We were sitting in the bar with the different people from CyberLife, and they were just, it was a really diverse crew. I think this is more, in a way, the rule.
And certainly, what we're trying to do with artificial life seems to bend very heavily onto a number of other people's fields of interest. I think this is part of the issue with regards to communicating, but also popularizing.
There have been a few good kind of meetings that have appeared through the years, meetings of strange detractors for engineers and whatnot, minds who are into this kind of thing. But me, I know I've always been in a bad situation working very much in a vacuum. I wasn't able to own my own modem until BBSs were almost gone. I spent 2 or 3 years on rural boards before I'm finally moving to a small town when they were finally eliminated. And I was just thinking to myself, I'd gone to that small town first, I could have met some people at the end of that era who would have become the kind of contacts I wished I had, because I'd never met anyone in that town, like one, two, who remembered anything about boards, and by then it was too late. And those were, I mentioned BBSs earlier, of course, that and Usenet, this kind of thing. There have been certain media that have really appealed to me. Just brought my ideas out, I thought, where there's a space where people could see them. And that was always very useful to me, and especially when I could achieve any form of collaboration, because I find I've done a lot of things from first principles.
And in terms of this idea of collaboration, I think this is something that I'm thankful for in some regard, although the kind of collaboration, when I list the people that I communicate with here, very few of them I've actually met physically. In fact, a majority of the people that I work with quite passionately associated with a majority of my developments I haven't actually met. It's one of these curious things. I meet Bruce Damer. I've met Bruce Damer, I think, once or twice, but those two meetings, have been extended kind of passing on of information and social stuff. He's met my wife. I haven't yet met Galen. But, it's quite overwhelming that a majority of this community is now completely remote and isolated in some regard, although the Graytham meetings are slowly bringing more like-minded folk together, and I find it quite inspirational. Although I'm in a city with a population of 1.5 million, artificial life isn't really part of the Las Vegas community. However, there is a huge community out there that's available and accessible electronically. I know, Eric, you've talked about your own wishes to get together with a Graytham community in your area, and certainly we talked last night with regards to folks in kind of broader Canada and up to Montreal and obviously Calgary and Manitoba, where Dick Gordon is. The Canadian artificial life community is relatively well spread. But certainly there is potential for regional conferences, and this is something that I passed back to Dave Kerr a year or so ago, that if you folk had a Canadian A-Life conference, I think a lot of folk would come up from the US and potentially, Gerald has a familial connection to Canada and may even choose to return. So, I think there is potential for small regional conferences to bring the community together in a physical location. Eric, Gerald, feel free to jump in at this point.
Yeah, I know what Eric's talking about. It's a very hard thing to do. I mean, the only real way you can meet the right people is via the internet, and if you're lucky enough, you get to visit one once in a while, and like you were talking about, Tom. That's the best we've got. But fortunately, we've got all sorts of communication media if we want to use them. I mean, I'm a Canadian living in the Netherlands, and we talk on a regular basis. If we really wanted to, we could see each other's faces on Skype. So you can, if you make the connections, you can use them even if they're electronic. Although, I guess I would like to go to a Biota, whatever 5, I suppose it would be now. And have us all together in one room. That would be just totally wonderful, but it might not be within the realm of possibility.
I think this is an economic component as well. I mean, certainly the history of the Biota conferences came at periods where the participants in the community had the necessary spare cash to go to a conference, or they had sponsorship, or they had employers that were receptive to them going to this kind of conference. And I mean, this returns to the idea of the artificial life winter that the circumstances currently don't necessarily lend themselves to large Biota conferences, or even Biota conferences where a majority of the community would participate. I mean, what I've said to Bruce is, if we have another Biota conference, it needs to be heavily sponsored and subsidized in such a way that we could get a majority of the community, or at least a majority of the participants in this very podcast together. I think it is possible there are locations where this could take place, but it will require a certain degree of, firstly, time lead-in, but also the potential to minimize excessive costs associated with that kind of meeting. I certainly was interested in what was being discussed with regards to the potential of some kind of get-together in London. But in the short term, I mean, do you see the Building Grey Thumb movement as being a positive thing in this regard, Gerald?
I was just thinking right now, what would Dick say? And I bet he would say, well, why don't we meet in Second Life?
Yeah, I think that my concern is always that the casual components of what these kind of meetings bring, the idea of, as you say, as you've talked about previously with regards to the bar meetings in Biota 2, and the ability to actually see people and just have casual conversation. I mean, when I reflect on the 2 meetings that I've had with Bruce, the nicest stuff has actually been just shooting the breeze with regards to a wide variety of topics that have nothing to do with artificial life. I mean, I think Bruce in particular is sufficiently the polymath that there are so many varying overlaps and so many things that when I talk to Bruce on the phone, our Biota-related discussion is usually around 20% of the conversation. I think this is what's, fascinating and interesting, and certainly through a passive way, I know a lot of us use and abuse Facebook and YouTube and these kind of things as a means of keeping in contact with people in both a artificial life-related and also social manner. But I think the ability of having these kind of conferences is really the downtime, the breakaway components, and I think my own personal experience with regards to Second Life leads me to think that the interface that I have through these podcasts is probably considerably better than the interface I would have through something like Second Life. Eric, I mean, what's your thinking with regards to, firstly, what we're doing through these podcasts versus something like Second Life versus a conference? I mean, you sound like someone who would ideally like to have a Grey Thumb on location, or even better, a Biota conference on location.
It'd be amazing, obviously, to have a meeting sort of on the ground in Toronto where people can go and exchange, like even just runs, just parameters and organisms and various outputs and inputs, as well as applications. We bring an air competition to the thing for people who are working on projects that have any overlap or no overlap to become friends and want to compete. This kind of thing is really important. Eric, if it can be achieved. I've talked in Toronto about the possibility of starting a meeting here. I think at the U of T, the University of Toronto, and that might be something we can follow up on about later. I mentioned 1 or 2 projects to him that I did not finish. I didn't get back to him yet, but that was a month or 2 ago. I've been busy, but I plan to sort of go through. I know a few people who while barely aware of the field, would sort of come to that as well.
Hey, Eric, if you're in Toronto, I'm going to be there for the holiday season, so we could meet.
Try to send me an email at some point. My address is on the list, so you can send me an off-list email. Any of the, I think I'm on the Darwin at Home list, as a matter of fact, so you can, tell me if you want. We can try
Great.
to. But that would be fun.
Here's another idea, because I've been looking at the Dorkbots community in parallel to what's going on with Grey Thumb, and there seems to be a solid overlap between what could happen with the Grey Thumb chapter and the Dorkbots community. I know the legacy associated with the creation of Grey Thumb came through a local game developers meeting that was held on a regular basis, and there were a component of the game developers that liked talking about artificial life. So I think we could almost have a parasitic Grey Thumb, or a series of parasitic Grey Thumb movements that came through things like Dorkbots. I'm pretty sure there's a Dorkbots in Toronto from memory. I know there's one in Montreal. I'm pretty sure there's one in Toronto too. So Eric, this could be a good venue for you to start talking about artificial life for, if not completely like-minded, at least a sympathetic crowd.
Yes, really anywhere, It would be good to give a presentation to a Linux users group about the Unix software available for this kind of work. You might snag a few minds that way. I mean, a lot of the Unix software is fairly serious sort of laboratories for this kind of work, where you can really see the primary principles just sort of expressed and proven time and time again. A lot of the more complex models sort of require some faith to spend a lot of time with, unless you've interrogated their internals very deeply.
Certainly. Yeah, I think there are a number of parallel veins. I know we spoke yesterday with regards to the idea of computational spaces, of actually having studios with a wide variety of machines interconnected, and certainly that's a central theme with Dorkbots as well. So, I mean, you may find the local collaborators that you were looking for in that light too. So with 5 minutes remaining, we should probably conclude the discussion today with regards to what we have to be thankful for in terms of artificial life developers. Gerald, is there anything that we've missed?
Oh, well, we've missed, the giants upon whose shoulders we're standing. We should be thankful for Darwin and Dawkins.
And also, I guess, a wide variety of other folk that have contributed to artificial life as well. I mean, I think certainly it goes back to Hobbes, as the Grey Thumb mailing list showed. I mean, there have been a wide variety of philosophers that have contributed various snippets. I mean, in my own work, and the likes of Bertrand Russell and Kant, and a wide variety of folk prior to Dawkins, and some prior to Darwin even.
Sure, and then we've also got Carl Sims and Tom Ray, and thank you for Jeffrey Ventrella. Let's go on and on.
Yes, I mean, when Eric was talking about the facial recognition, that comes through Jeffrey Ventrella's work in gene pool as well. I mean, I read his paper periodically to get new stuff, and he has a kind of racial, non-racial attractor that's based purely on the color patterns of the various swimming creatures in gene pool. So I think Jeffrey is just inspirational. I think there are a number of people in the community that are inspirational to talk to periodically. I also think of John Klein here, because he's so humble in his communication, but you get the sense that he has so many ideas that are instigated and come through discussion. So, I mean, we're very lucky in terms of the wide variety of once contributors and current contributors that we have in the Biota community. Anything else that you can think of, Gerald, to be thankful for?
Well, let me see. It just depends on how it turns out, how it all unfolds. But you might even want to be thankful for the financial crisis if people get more time to work on their hobby projects. Yes,
I think it's a catch-22 situation because, ideally I would like to see artificial life developers prosper through a new financial prosperity that isn't derivative traded and future destroyed. I think we have a great source of knowledge that could actually generate new and exciting technology that will hopefully be independent of future financial fluctuations. Eric, with just a minute remaining, do you have anything else that you think we should be thankful for?
Oh, I don't know. I think automated trading is looming very large on the horizon right now for a lot of people. If someone installs something standard on the OLPC laptop, where you can get a free account, that you move some money into from your bank account and it starts to increase right away, it could actually end a lot of problems in the world. This is not so different from hill climbing. I think that's very, very important. We should be thankful, that this is happening at all.
Very interesting. Well, I'd like to thank you both for the opportunity to jam with you today. I mean, I think this is the nature of these extended Biota lives, that we're looking to get folks such as Eric and Gerald together, and I'm looking forward to the next couple that we have coming up. Our topic on tomorrow will be a standard Biota Live, where we talk about the hobbyist aspects of artificial life. However, this will all appear out of sync with regards to what's going on. So thanks to Eric and thanks to Gerald for the chance to chat with you both today.
It was a nice chat.
Goodbye.